All right. So first of all, packages and namespaces, right? So I've seen many of you did coursework on Python, right? And normally in the coursework you present a script, you present a Jupyter notebook. But very often, even in in a bank or asset manager, people use Jupyter notebooks. People use single scripts, and especially with the Jupyter notebook. That normally one would run Jupyter notebook is that have a bunch of statements there which are executed by by the user in a particular order, and it's pretty hard to for anyone other than the author to figure out exactly how to run it. It's hard to reproduce. So generally, you can create a single script. You can create a single Jupyter notebook. It should be on Git, but it not always is, and usually it does not have tests. But that's not the right way. And even if you're at the university and submitting this as coursework, it's actually your professor, I assure you, will be very, very happy if you do one of these two other project types. Well, for course assignment, probably the second one, right, not the third one. But it takes very short time to set up, and it's actually make your code more reliable, easy to work with, and easier also for others to understand, right? So the second way that I recommend is a small enterprise open source project style of package, which normally has a single namespace. And some large packages even have a single namespace, but especially small ones. Single folder, possibly with a few subfolders. A separate test folder, right? So it should not be the same folder as the main folder, because when you ship the code, when you package it to put in a Python package index in a PyPI repository, you don't want to actually necessarily ship the test, even though sometimes you want to do that, right? Sometimes you don't. So test folder should be separate, and it should be on Git, and it's usually a single Git repo. But for large enterprise open source project, it does not always work this way, because often a large enterprise project, it does multiple things, right? For example, there's maybe a core library. Let's say if you're talking about risk management application, you may have a library for dealing with trades, and you have another library for dealing with risk scenarios, and they are often developed separately by separate teams. So you need a way to have multiple namespaces, multiple folders, such that everything works together, right? And there is various styles of doing that, and the way that we recommend have to do with a Python feature called namespace or implicit namespace packages. And this is described in PEP 420, right? So the larger the numbers, the more recent the feature. So you can see it's not one of these first features of Python. It appeared relatively recently. And what it allows to do is to create multi-level packages that can be next to each other or can be in a separate repositories. And this way, you can have a kind of a consistent naming where there is a basically common hierarchy of namespaces. But each of these namespaces, each of these leaf namespaces at the end, they can live in a separate Git repositories. Separate teams can work on it. It can be subject to its own release schedule. This is how you can keep consistency, so you don't just have to come up with completely random names, and that would make it unclear how things are related to each other. But have a clear hierarchy, but not have to put everything in one folder. So that's the first hands-on exercise. And with that, let me switch to PyCharm. 1 second, where is it? It's somewhere here. Okay, there. Right. So here's the way that we set up. And again, that's not the only way to set it up. We just selected a particular style or convention of how to name packages. But the key thing here is that you can have a multiple level namespace, right? So this is the CL folder. And the first level of this folder, 1 second, let's just open it in Explorer so it's easier to see. So we have, this is the root of the Git repository. I recommend to put all of the source code under SRC, or sometimes it's called lib, such that you can put next to it things which do not have to do with source, and your source directory is not polluted by other things. You can, of course, put things inside source because you still have the root namespace, but especially when you have multiple root namespaces, right? So I have root namespace here, CL, which the reason I called it that because at Compatible we have a common prefix, so we can immediately see that this is something that one of our projects and not a client project or open source project. So when you're working, basically you could base it on your initials or on your employer. We put all of our code in CL, right? And sometimes you also put here, if you're working on a project, on a library and a project using this library, you may have another namespace here. So you can have two next to each other. So then the thing is, once you have a lot of them and also other things, hard to see which one is a namespace package and which one is not. So we recommend putting code in src or lib. And then, as you see, our Robert Frost, the road less traveled poetry is in this folder. So it's next, actually, well, it's empty because it's on a branch. You can put other things here which are not source, right? So in source, you put source code. And all of these other packages is what editors create to keep track of cache, Python and PyCharm and so forth. And there's a VM here, of course. Okay, and then under that, you can have your project name again. So I'm demonstrating the common feature of multi-level packages, the way that our convention of naming these packages is you can always change this. It's not the standard. It's not one of the things that you have to follow precisely or at all. But the way that we did it is that next to this project name, right? So in this case, it's Enterprise Python because this is the code for this course on GitHub, and I will share the link, by the way, at the end of this lecture. And it may be project A, project B, and so forth, right? And finally, inside you have core, where the main Python code goes that you ship. Then tests. You can have singular tests or multiple or plural tests where the tests go. And both of them can have subfolders. And you also have things like mocks, right? So we don't have any mocks yet. But what mocks do is sometimes you need the resource for your testing that is hard to make reproducible. Like, for example, it may be some third-party API. A classic example mentioned in Python, well, Python not necessarily, but testing, textbooks is a clock, right? So you want to test the response of a clock, but you don't want to run your test in any particular microsecond of a day. So you can have a mock clock that always returns a particular time of day, right? So that's an example of mock. So mock is a class that substitutes some resource or, like, for example, a connector API that has unpredictable or time change, behavior that changes with time and produces standard response that you can then use in regression testing. And mocks should be in a separate namespace, ideally, because you don't want necessarily to ship them unless you're also shipping tests, right? So sometimes you want to ship tests so the user can test. Sometimes you don't want to ship them so the namespace is not polluted with tests. So mocks is something that is not core because sometimes you don't want to ship it and you always want to ship core. But also you don't want to use tests as references, right? That creates all the problems particular to Python and various tools. So you don't want to import anything from tests, right? And you don't want to put them in core. So it's a separate folder. And CMD usually is a good way to have kind of one-off script. Like, for example, configure the database, configure something that you run once, right? So we put it in CMD. Okay, and then here you have the source. And the key thing about namespace, implicit namespace packages, so the PEP 420, is that you have to choose that if you put code in something, everything under it should be in one place. So I can have Enterprise Python folder here, a couple of other folders next to it, or I can put each of them in a separate repository. I can even go here, and because I don't have a need at this level, I can put core in one Git repository and mocks in a separate Git repository or a separate branch, right? And tests in a separate branch. But finally, when I get here, everything under here, once you see any Py file, that's it. From there, you have to be in a single folder, right? So that's why you can make it a little bit more scalable. What we're using for that is namespace packages.